So hello one more time. We're happy to see all of you here today. Today's webinar is twice as extraordinary. Firstly, our today's speaker is incomparable and charming, our chief marketing officer, Elena Malec. And secondly, today is actually RULA's birthday. Taking this wonderful opportunity, we would like to thank all of webinar participants for your interest and desire to extend your knowledge together with us.
Yes, and thank you very much. I'd like to say hello to everyone and thank you for joining us on this special date. Today, I'm substituting for old-time lecturer Philip Stumscheis, who unfortunately fell ill, but we didn't want to push the webinar any longer and to keep you waiting. So I'll try my best with the help of our support team to give you an overview of fatigue testing. We'll just give you a brief introduction. And as we wait for more people to join, so there will be a 5 minutes introduction and then we'll just go on and dwell into fatigue testing. If you have any trouble hearing us or seeing the presentation, please let us know. You can use the webinar control tool. So you have the arrow button that you can press and the questions section unfolds. This is where we'll ask you to tap if something is wrong with the sound, if you cannot hear us, if you cannot see the presentation, and if you have a question.
Yeah, so let me tell you a few words about RULA technologies. RULA is a leading-edge European manufacturer of test and measurement instruments. The company is headquartered in Riga, Latvia. We implement solutions for automotive, aerospace, and research, as well as other industries. RULA mainly manufactures vibration controllers, data acquisition systems, and softwares. By the way, there are 3 types of softwares that we manufacture. These are Testup, Signal Up, and calibration software. Testup was designed for vibration control and Signal Up for signal analysis. Our today's topic is advanced fatigue testing, and we are going to discuss the differences between Sine resonance search and fatigue test, then perform live fatigue testing session using different sensor types like laser vibrometer and velocity sensor, and show new features for working on resonance frequencies. As usual, we encourage you to ask questions all through the presentation, and we will monitor them and try to answer them right away. But if the question is complicated and needs a more extended answer, then we will answer it in the end. We also have a raise your hand tool so that you could let us know if anything goes wrong. So I think everything is clear, and without further ado, I can give the floor to Elena Malec. Elena, you're welcome.
Thank you, Alina. Yeah, so as you said rightfully, we're going to be dealing with fatigue testing. It says here fatigue testing theory. It's not going to be much of theory because generally fatigue is essentially a resonance search with a set of more complicated settings. So if you are familiar with resonance search, then pretty much fatigue will not be a very big challenge for you. So in fatigue, as well as in resonance search, we're going to run a sine sweep, we're going to search for resonances, and then we're going to dwell on resonances in a specific way. So the theory here, as in RSTD, is first of all the definition of a resonance. I'm sure you're all very well familiar with that, but just to observe the formality, let me give you a definition of a resonance. So a resonance, as you know, occurs when the product is exposed to an external vibration occurring on its natural frequencies. And in this case, the oscillation becomes very significant. It can be very damaging. The object can break or deform. It can cause a lot of damage to parts of the product or all of the product. And therefore, RSTD or resonance search has become an industry standard in many standards, including, first of all, aerospace, automotive, as well as many others. So a legitimate question would be, why do we need fatigue then if there is RSTD? The purpose of fatigue is a little shifted. So it's not only to find the resonances, but to test, to dwell for a very long time on maybe each of them or in the majority of them, and to test how long the object can survive under the resonances. This is why the resonances are worked on for a long period of time and very often until the object breaks. So what we will be showing here today will be an illustration of how one would work with the turbine blade and how we test fatigue of a plain turbine blades. So let us introduce our setup.
Yeah, in the picture you can see the common setup which we actually usually use. So these are RLC21 controller, RLA200 amplifier, a shaker. On its table we have mounted a turbine blade model which we printed on 3D printer. On the top of the picture, we have a regular IEPE 10 millivolt per G accelerometer, and for resonance tracking, we are going to use a laser vibrometer. The concept of the fatigue testing is based on the idea that we don't influence the testing object with other mass, like sensors and additional fixture. Using this test type, we can influence our object with sine wave, search and track its resonances, and control the test run with laser displacement sensors.
Yes, that's right. And if we want to focus a little bit more on the differences between fatigue and RSTD, I'd like to point out that if in RSTD we just dwell on one resonance after another, here in fatigue we will be able to work on several resonances simultaneously. Plus, we can create a complex schedule on working on resonances. For instance, set the different levels of work, and we will be able, for instance, to maintain the amplitude on the resonance channels, which is not available in RSTD. And we're going to illustrate it as we set up our software. So let me just go to software. We're going to run Testup. I have a preloaded test here, but just to give you an overview of the logic of working with our system, I will go through all the steps together with you, starting with the very beginning. So it's going to take a few seconds to load. As you see, fatigue test is already selected, but if I were to start it from the beginning, I would first go to the channel settings in the configuration test tab, and I'll make sure that we have all the correct settings here. So my first channel is connected to an IP accelerometer with 10 millivolts per G sensitivity, and the type is IPE. As you know, we pay a lot of attention that the units are correct and that the type matches. And the second channel is connected to the displacement sensor with 90 millivolts per millimeter units, and in this case it's linear, so it has its own power supply and a voltage output. Everything is okay here. I can add a new configuration, or I can choose one of my previous configurations. It's all good. And we're going to create a new test. So I press the test type selection button and I go to fatigue. And here we see the profile tab opens. Let us set it up. Our start frequency will be about 10 Hertz and the end frequency of the first row about 30 Hertz. the start amplitude of 0.5 G and the end amplitude of 3 G. And I'm going to add another row. And in this row, we'll maintain the same amplitude of 3 G, but we'll climb up to 150 Hertz. Next step is schedule, and we will only have two commands, run profile, and the second command will be obviously resonance search. And this one is the most important tab because these are the settings of our resonance search and then the settings of tracking or dwelling. So let me select the reference channel. Actually, it's going to be channel 1 because this is our IP sensor, and then the response channel will be channel 2. I can see here channel 3 and 4 really don't need them, so I'm going to the channels tab and I'm going to disable. This is a 4-channel system and we'll only need 2. Okay, now we go into search method and you can see a drop-down list with 3 methods available: transmissibility, Q factor, and the first transmissibility derivative. Just to remind you the options that we have in Testup software, transmissibility is based on the relation between the reference and response channels, and the peaks of this value are considered resonances. We've added one more mathematical resonance search method. It's the first transmissibility derivative. As clear from the name, in this case, we calculate this first derivative of transmissibility, and then we find the points where it switches its sign from plus to minus and count them as resonances. And maybe a more familiar method will be Q factor. So Q factor is the characteristic of the steepness of the resonance and therefore the potential damage. And it's calculated, as you can see from the graph, as the ratio of the center frequency of the resonance to its half width bandwidth. Okay, and going back to Testup, I'll probably just choose transmissibility for this one as the easier one. And then we have sorting results. We can sort by frequency increase or decrease, by Q factor, by transmissibility, by amplitude, any way we want. Then comes the frequency resolution settings. It is quite important because according to this value, we're going to differentiate between resonances. So if the difference between two resonances is less than 1 Hertz or 1%, it's going to be considered 1. Okay, now let's go to the tracking settings. And in tracking, what we want to specify first and foremost is the emergency stop settings. So if, let's see, we dwell for a long time and we dwell to a point of deformation or break of the object, we may not necessarily immediately see it, but we will see on the graph that the frequency is going to shift. So here we specify the shift of frequency after which the system considered the object to be broken, and we want to go into the emergency stop, not to continue the impact. Here I'll leave it at 1 Hertz. We also have the phase tracking settings here. I'm not going to change anything in there. So that's about it. I'll just double check that we have the right shaker. That's right. We have a Tira shaker this time, and the channels are correct. So we can apply. It says load mass is 0, but this is obviously will not be this way, but for the demonstration purposes, it's okay. And let me call it, set the configuration, and we can run the test. It's going to take a little time to start up. And immediately you can see the data panel right here. So it shows live the data on each channel, on your response channel, and on your reference channel. You can change the information you want to be displayed. So for instance, if you feel like you don't need this, you can uncheck the box. Now the test is running and we can call a number of graphs. So we have here acceleration versus frequency, but for instance, we're tracking by transmissibility. So we may want to call transmissibility versus frequency so that we observe the peaks of transmissibility. Now this time we're not showing the setup on camera, but I think it's quite audible so you can hear the vibration, and I think it should be going into some resonance quite soon. There we go. We are almost done with the first segment of our sweep and coming into higher frequencies with a constant amplitude.
While we're watching this process, I think we can discuss several questions that we have already got. So the first question is, do you have a resonance work logbook?
Okay, so yeah, it says here resonance work logbook, and I think it's coming from someone who is already expecting the next version of our software. So I'm showing you now the stable version, which is available to every RULA user and Testup user. In this version, it's not implemented yet, but it's going to appear this spring, and what it's going to do is going to show resonances live. So all the resonance data will be displayed as a separate panel. As we have the data panel here, we will also show the resonance workload. So it's basically like log, but devoted to resonances, and it's very easy to work with them then. And if you are interested, please let us know in the follow-up. We can share the preliminary version with this new feature in the follow-up.
There is also one more question. I think it's kind of similar because, well, this feature will be available in the next release. So the question is, does Testup have an ability to log the resonance work and save journal?
Yeah, well, it's the same thing. Yeah, so it's the same thing that I've just said. It's going to have it. Well, it has a resonance panel that we will see right after the resonances are found on the second stage of the test, but now it's not live. Yeah, so the functionality is a bit limited. Yeah, so we can see some quite steep peaks here. So I think we are going to get our resonances, and the test is 95. The search is 95, 97% complete. So as you saw, the resonances were highlighted, and this is where it becomes specific. This is where it's not exactly like the RSTD. So we have our resonances table. As you see, they're sorted by frequency increase, but if we want, let's see, for instance, by transmissibility increase, so you can see the resonance with the biggest transmissibility here at the end. And I can choose on which resonances I want to dwell. I can choose one or more. So I'm going to choose this one, the most significant one that I want to work on. And right here, after we found the resonances, we can change the emergency stop settings. So we can change the values which will be considered by the system that the object is broken. So I want to give it a little more space to make sure it dwells on the resonances for a longer while. Yeah, another thing we can do here is we can add a resonance. So if I look at the graph and let's say I see peak, but it's not on the table, so maybe the Q factor is not high enough of the transmissibility, it's not considered to be a resonances, but I want to dwell on it, I can add it manually. and I'll calculate the parameters, and all the parameters like amplitude, Q factor, transmissibility are here, and I can add them. And you see it appears here on the table. Now let me also change the maximum amplitude. So it's a safety setting, so I don't want the range of amplitude go above 10G. And then we can maintain the resonance amplitude. This is definitely what we're going to be doing. It's not available in RSTD, but available in fatigue. And as you can see, I have the take work time into account setting. And here we can specify for how long you want to dwell on the resonances, either in minutes, hours, or in cycles. So we can choose cycles this time, let's say 6,000 cycles, let it be that. Okay, and let's run the first dwell. I haven't ticked the box in this one. So the dwell starts. Let me just call oscilloscope. I'll switch to spectrum scope here, and you can see our peak. So it's going to do exactly 6,000 cycles, and you'll see the value right here. At any time, I can stop dwelling on the resonances manually here. There is also a manual control panel where I can tweak the level, so I can increase or decrease the level. I can set the frequency as well. Okay, now let me try and choose 2 resonances to be working with simultaneously. So let me choose the lower one here. I will also change and set the frequency shift the same so that we can definitely see it for a longer while. Okay. And this time I'm just going to specify, let's say, maybe 1 minute, so that we see it's not a cycles, it's in minutes now. In our spectrograph window, we can see the 2 peaks very clearly, that it's dwelling on 2 frequencies, on 2 resonant frequencies at the same time. Quite audible as well, so obviously it's a more significant impact. And I can see the question here.
Yeah, how many resonances can be dwelled on simultaneously?
Up to 8. We can do up to 8, so it's basically a multi-sine wave. So it's up to 8, same as the advanced sine capabilities here. Here we go. I'll uncheck this box, and maybe the last thing that I'm going to show here is the capability to set the extended schedule. So it's not in minutes, like one profile and that amount, one frequency and that amount of minutes. But in this time we can add the levels. So for instance, I want to be on the 100% level for 20 seconds, then 20 seconds at say 120% level. So I'll rise it, and 140 for yet another 20 seconds. Okay. And yeah, before we go, I'll also like to comment on a few more settings here. So we have this checkbox, start up outside the resonance. So as you may know, it's not always easy to start up at a resonance level immediately. So in some situations with some objects, it's just not going to happen. So what we need to do now in this case is to start a little bit before. So we set this value, for instance, 5 Hertz. So we'll start not on the resonance frequency, but 5 Hertz to the left, and then climb up to the resonance quite smoothly. Then another thing here is that we allow resonance adjustment all the time. So just to remind you, as the fatigue accumulates and as the object deforms, the frequency may shift. And if we continue to impact on the same frequency in this case, the product will not be subject to the proper impact. So we will not be testing it on its resonance then. So if we allow this resonance adjustment as we do, we make sure it still stays on the same frequency. But then it's regulated by our emergency stop settings. So we go back and let's see this working with an extended schedule. Let me just open maybe a very basic acceleration versus time. So we'll see the levels right here. So this was the 100% level, then comes the 120%, and in 20 seconds it climbs to 140. Yeah, so that's about it for now. We're gonna have more functionality, a little bit even more extended and intricate set of settings in version 59. As I said, I repeat, if you're interested in preliminary version, we can share it after the webinar. Yeah, let me just summarize by saying that we've showed you some of the differentiating features of fatigue compared to resonances. I'd like to point them out once again. So not just one resonance is available, not just one frequency to be dwelt on, but up to 8. Then in Sine test, as you know, and if you're a RULA user, you probably know that the control options are very simple. The view is quite basic, but in fatigue, there are a lot of advanced settings that we have just shown. There's even a little more. So as you work with the resonances, as you dwell upon it, you can have a more illustrative picture of the resonances on your object. So in Sine test, RSTD is used just for resonance search, so to find the resonances, while fatigue is more applicable for the procedure of dwelling on the resonances, and especially if we're talking about some very sensitive objects, dwelling for a very long time, where safety is crucial. So long duration and destructive test and fatigue is your go-to test. So let me just sum it up. We have gone through some fatigue theory, discussed the differences, differentiating fatigue from RSTD. We showed you the resonance search method. We showed you how it's specified and run in our software. Talked about the frequency shift, the emergency stop and the frequency adjustment and how it's quite important for this type of test. We made a model of a fatigue blade, or rather, I guess, a fatigue material, yeah, which is treated in this example test as a fatigue blade would, and gave you a live example. We didn't manage to break it though, because it would take much longer than the time we have during our webinar, and we compared regular Sine and fatigue. I hope it was useful. If you have more questions, if you'd like, I don't know, a live session, or you'd like to learn more about fatigue in RULA Testup software, please let us know. We will be following up shortly after the webinar, and the video will also be available for the participant quite soon. So usually we make the videos public in a little while for those who were not present, but for the participants, it's immediately available so you can share it with your colleagues. If you still have questions left, we had a couple of questions.
Yeah, I can see the question right now. So the question is, can I test the object in fatigue test type without laser vibrometer? So,
yes, those things, it is RSTD, like theoretically, of course, you can use, instead of a laser vibrometer, you can use an accelerometer. So there is nothing technical which prevents it, but as we said, using a displacement sensor allows you not putting any extra weight on the blade or on your object, so you probably wouldn't want that. Alternatively, if you don't have a displacement sensor, you can use a plain strain gauge, which is like a very thin strip, and you place it on the blade, and as it deforms, it becomes your response channel instead of a displacement sensor. I hope it answers your question. So yeah, we'll just stay here with you for another couple of minutes. So if you have more questions, please don't hesitate to use the webinar tool. On the screen, you also see our contact details, so our support, which is available, very agile. So if you have technical questions, don't hesitate to ask them. And for marketing questions, you can use contact@rula.com. Please browse our LinkedIn page, our website. We try to be helpful and extend our knowledge base regularly. You can also use the QR code on the screen to access RULA YouTube channel, where you will see the collection of our webinars and the collection of our educational videos. And last but not least, please follow our webinar schedule. We'd be happy to see you, your colleagues and your clients at these events. Thank you very much for your attention, and keep in touch.
thank you for being with us today.